Hello students, and welcome to our topic on perimeter and area. So the point of today's lesson is that we're going to solve some practical problems requiring the calculation of perimeters and areas of circles, sectors of circles, triangles, rectangles, trapeziums, parallelograms and composites. When we look at our summary of our length, area and volume unit, so this is mensuration, which is the act of quantifying and measuring. We're looking at 1, 2 and 3 dimensions. So when we think of perimeter, we're thinking around the distance around the outside of an object. So we're going to use units such as the meter, which will be our base unit, and then we can use things like centimeter, millimeter and so on. And the types of calculations I'll be requiring you to do with distance are going to be perimeter. Now the important formula for a perimeter is, first of all, just add up all the sides, or in the case of a circle, the circumference or the perimeter of a circle is the pi times the diameter, or 2 pi r, which you should be quite familiar with. The second half of today's lesson, we're going to be doing some area calculations as well. So area involves 2 dimensions, and so it needs square units. So the units of distance are multiplied against each other, so they will be square units. So for example, we will therefore use square meters. So today we'll look at also area of 2D shapes, and here's our important formula that we'll look at today as well. So the perimeter, as I said, is just the distance around the outside. So we'll work with units like millimeters, centimeters, meters and kilometers. And we just need to be careful from going from a smaller unit to a larger unit. So when we do that, we divide by the relevant conversion factor, as you can see here on the right hand side, because we know that the answer must be in a lesser amount. So when converting from a larger to a smaller unit, you'll multiply by the relevant conversion factor, since we know that we require a greater amount in the result. So if we want to convert some of the following, so what is 30 centimeters in millimeters? Well, millimeters is a smaller unit than centimeters, so we're going to have to get a bigger number. So we're going to multiply it when going to a smaller unit, and we're going to go from centimeters to millimeters, so we multiply it by 10. So 30 centimeters by 10 millimeters per centimeter will give you 300 millimeters. Now, if we go from 4.5 kilometers to centimeters, what are we going? So we're going 4.5 kilometers, and we're going to take a couple of steps, 1 and 2. So we're going to have to multiply it by, first of all, 1,000 to get it into meters, and then by 100 to get it into centimeters. So what you will write down is 4.5 times 1,000 times 100 to give you 450,000 centimeters. Last of all, if we want to go from centimeters to meters, we're going bigger unit now. So meters is a bigger unit, so we're going to go the other direction, and so we're going to divide. So 456 centimeters into meters, we divide that by 100 to get 4.56 meters. You should also be familiar with particularly the milli, the centi, and the kilometric prefixes. So a millimeter, for example, is 1,000th of a meter. We can say that is 1 millimeter is 0.001 meters, or 10 to the negative 3 meters. Now a centimeter, you know, is 100th of a meter. We can write it as a fraction or a decimal, or in index form. Now deci means 1/10, so that's where we have our decimal system from. For example, a decimal is 1/10 of the next unit, so we write it as such. Whereas deca is 10 times that unit, so that's 10 to the power of 1. Hector, so you may have heard of hectopascals, for example, on the weather report. So that's particularly with air pressure. So 1 hectopascal is 100 pascals, and that's a convenient one for us to use for that one. We don't use it too much, yes. And a hectare just means 100 times. And kilo, you're familiar with, is 1,000 times. I suppose you could also recall mega, which is 1,000,000 times. So a megabyte is 1,000,000 bytes, or roughly. Giga, what's that? It's a billion, and tera is 1,000,000,000,000 times that. When it comes to solving problems in maths, you still need to run through the problem-solving steps. So we want to be able to plan how you're going to approach the problem and read the question, and to translate that into mathematical terminology. So using the right symbols and operators, etc. And then you need to document and identify your assumptions and the variables and observations. So that's often involving drawing a picture and selecting the correct formula. When you solve, you're going to select the right procedure and apply it. So you're generally substituting and coming up with the solution. Evaluate, just check the reasonableness of your solution in the model unit. So you want to be checking units, for example, and any transcription errors, etc. And then lastly, you just communicate clearly and concisely. So if the answer is written as a question, if the question is written as a sentence, answer in a sentence is a classic example there. If we look at the perimeter of various shapes, so a square is a four-sided shape with all equal sides. So if I know that they're all equal, all I need to do is measure one side and multiply it by 4. Likewise, with a rectangle, I know that 2 of the sides are equal, so I just want to measure the width and the length, add them together, and multiply it by 2 to get the perimeter. Other polygons, you're just going to add up all the sides and count them individually. A circle, as I mentioned before, it's either 2 pi r or pi d. Remember, 2r equals a diameter, so 2 radius for a diameter. A sector, you're going to have to add up, first of all, the 2 radii, and then look at the proportion of the circumference. So you're going to use a fraction for that. And it's just the angle here, the magnitude of the sector, over 360 degrees in a circle. So you're going to multiply that by 2 pi r, which is your circumference formula, and then add those 2 radii on. So if we have a look here at a trapezium, so calculate the perimeter. Well, it's just going to be easier to add up all the sides. So what have we got? We've got 25 plus 30 plus 2 lots of 20. This sign here, remember, means that both of those sides are the same. So that should give us 95 meters. If I want to have a look at a circle, calculate the circumference of a circle. Remember that's 2 pi r or pi d. In this case, we are given the radius, so we'll just stick with that. So it's just 2 times pi. So use the pi number on your calculator rather than typing in 3.14, and then multiply it by 20. So the answer is in 125 and 66 millimeters. Now remember to check your units. They are in distance units, so that's fine. Now with the sector, remember we have to add those 2 radii and that proportion of the circumference. We call that partial circumference an arc. So in this case, there's 270 degrees of 360 degrees of a circle. So there's our proportion fraction. And then we're going to multiply it by 2 pi r and multiply it by 2 radii. Sorry, add the 2 radii on. And so we'll just substitute in now. So 270 over 2 pi times 20 plus another 40. That should give you 44.7 millimeters. The area is the space within a boundary of a closed figure. So we're going to use square units. For example, millimeters squared, centimeters squared, meters squared, or kilometers squared. And the units for land are hectares, and we use the symbol HA. If we want to convert now between these units, so if I want to have a look at 30 centimeters and want to convert it to millimeters, do remember we're working with square units, so the numbers or the conversion factors are going to be squared as well. So you know that there's 10 centimeters in a millimeter, but there's 10 times 10 millimeters in a square millimeters in a square centimeter. So we just have to be careful of that. So 30 centimeters squared to millimeters squared, we want to go from what are we going to? A smaller unit. So we are going to go from centimeters and up. We're going to have to multiply it by 10 by 10 or 100 to get 3000 millimeters squared. If we want to go from 4.5 square kilometers, I didn't put those symbols in, into, where are we? Into centimeters squared. So we're going from here up to here. So we just need to think of those conversion factors. So there's 1,000,000 square meters in a square kilometer. So here's our first conversion factor. And then there's 1,000 square centimeters in a meter squared. So that's another conversion factor of 10,000. So we've got a very large number. So it's 450,000 million billion. So, oh, sorry, 45,000 million billion. So 45 billion square centimeters to that kilometer squared. If we're going from 456 square centimeters into square meters, where we're going from a smaller unit into a bigger unit, so we're going to divide, and we're going to use that conversion factor of 10,000 to get 0.0456 meters squared. If I want to think about a hectare is defined as 10,000 square meters. Now the square root of 10,000 is 100. So what we're really saying is 100 meters times 100 meters. So if you want to think of it as a square, that's quite easy. A square with one side of 100 meters. Now, if I have a look over here, if you've got a square piece of land and it's only 50 meters, it's important to realize that that's a quarter of a hectare and not half of a hectare. The logic behind that is 50 meters by 50 meters is 2,500 square meters. And you can note that that's not a half of a hectare, but 1/4 of 10,000 square meters. So with area formulas, you'll notice that we've got our formulas here. So we can have a look here. A square, well, that's just one side multiplied by itself. And for a rectangle, it's length times width. For a parallelogram, that's a little bit unusual, but you can think of this height just as the side of a rectangle, and you'll come up with the same response as well. So you can treat your parallelogram as a rectangle in the sense that the base or the length should be the same and the width and the height should be the same. Now a trapezium has one pair of parallel sides and it's a four-sided shape. So what you're going to need to do is add up the top side and the bottom side and take the average of that. So that's where we say we are half of that, of those two added together, and multiplied by the height. Now for a triangle area, we've got two important formulae. So the first one is if you were given the height. So here we go, we've got a height there. It has to be at 90 degrees, for example. And so it's just base times height over 2, or half the base times the height. Now, if you're not given the height formula, you're going to have to use Heron's formula. Now, you can also use Heron's formula to verify this one here if you have been given the three sides and the height as well. So, Heron's formula relies on the height measurement being unknown. So, you're going to have to substitute in the three different, so what do we got? S take A over S take B over S take C, where S equals a half of A plus B plus C. So it's like an average there. And that's Heron's formula. The area of a circle is just pi r squared. The area of the sector is just that proportion of the circle. So the number of degrees or the magnitude of the angle over 360 times pi r squared. So if we want to have a look at the area of the trapezium, well, it's the formula is a half of A and B added together multiplied by the height. So you need to know that one. So don't use the slant height, but use the perpendicular height. So a half of 25 and 30, well, that's half of 55. And then we're going to multiply that by 20 to get 550 square meters. To calculate the area of this sector, remember it's just a proportion of a circle. We've got 270 degrees out of 360 degrees, multiply it by pi times r squared, and we should get 942.48 square millimeters in this case. So here's Heron's formula, and you can notice that there's no height given. So we have to use Heron's formula because we're not given any height, for example, here. So that makes it a little bit more complex, but it's worth doing. So Heron's formula is just where S equals half of A plus B plus C. So that's half of 5 plus 7 plus 9, so that's 10.5. Once we've got S, we can start to substitute into the formula. So Heron's formula is the square root of S times S minus A multiplied by S minus B multiplied by S times C. So let's substitute into our formula. So S is 10.5, so you can see that consistently through. And then side A is 5, side B is 7, and side B is 9. And that should give you 17.41 square meters. As I said, if you need to verify using a more complex type of question, you can use this formula if the height's given, and for the other half a base over the height times height, sorry, to check your answer. Now, compound shapes are just when we have different shapes, when we're either going to add or take them away from each other. Sometimes we call them composite shapes. It's just a combination of the different shapes. So it's important just to break the shape into smaller shapes, and generally the shaded area means that it's subtracted in diagrams. So we find the area of the following shape. So we've got a rectangle and we're minusing 6 circles from it, but all we know is just one radius equals 2 centimeters. So we need to think, how big is that rectangle first of all? So we know that the radius is just 2, so the diameter must be, what, 4, and it'll take 4 radii or 2 diameters to go all the length of the height of that rectangle, and if we work our way across, it's going to be 6 radii across, so that's going to be 12 centimeters in this case. So now we've got the dimensions of the rectangle. We can say, well, our plan is going to get that one rectangle and we're going to minus 6 circles from it. So the formula for the rectangle is just length times width, and we're going to minus 6 circles, and so that's pi r squared and 6 lots of that. So 12 times 8 minus 6 times pi 2 squared, and we should get 20.26 square centimeters.